Let's consider a hiker. And the hiker is climbing up a hill. So here is our hiker. He carries a large backpack and he's just climbing up the hill. And let's say that the hill has a total height of 10 meters. So what will be the work done on this backpack by the hiker? What will be the work done on the backpack by gravity? And what will be the net work done on this backpack? And for simplicity, we will ignore any friction or drag forces, and we will also assume that the hiker and the backpack just moves at constant velocity, so there's no acceleration. Now, if we imagine the forces acting on the backpack, there is the force of gravity in the downward direction. There is also the force exerted on the backpack by the hiker. Note that the backpack is not accelerating, so the net force acting on the backpack should be zero. Since gravity, the force of gravity is in the vertically downward direction, the hiker should exert a force on the backpack in the vertically upward direction. And the magnitude of the force exerted by the hiker should be equal to the magnitude of the force exerted by the gravity on the backpack, so that they would cancel. The net force would be zero. And the force exerted by gravity on the backpack is, well, let's assume the backpack is 15 kilogram. This is the mass. The gravitational acceleration is 9.80 meters per second squared. So the force the hiker exerts on the backpack is 147 newtons. Now let's calculate the work done by the hiker. So the displacement, let's say the total displacement, the hiker climbs 10 meters from the initial point. This is the total displacement d. Let's call this angle theta. Well, if that angle is theta, this angle over here is also theta. So the work done by the hiker is the force exerted by the hiker on the backpack multiplied by the displacement, magnitude of the displacement, multiplied by the angle between the force and the displacement. The force is in the upward direction, the displacement is in this direction, and the angle between them is theta, so this is cosine theta. The force exerted by the hiker, we had calculated it to be 147 newtons. Note that d is the hypotenuse of this triangle. Theta is this angle, so d times cosine theta is just the length of this side, which is known to be 10 meters. So the work done by the hiker is 1,470 joules. This is the work done by the hiker on the backpack. Now let's calculate the work done on the backpack by gravity. Work done on the backpack by gravity is just the force of gravity acting on the backpack, the displacement of the object multiplied by cosine of the angle between the force of gravity and displacement, which is just, this is the force of gravity, this is the displacement. So this is the cos, we have to multiply it by cosine of this angle, but that angle is cosine of 180 degrees minus theta. So this is equal to minus, or force of gravity times d. Cosine of 180 minus theta is just minus cosine of theta, or minus fg d times cosine theta. But you see, we already know that force of gravity and the force of gravity on the backpack and the force that the hiker exerts on the backpack, they have the equal magnitude. So this is just the equal in magnitude to the force exerted by the hiker on the backpack. So it's actually fgd times cosine theta is just fhd times cosine theta. So this is equal to minus 1,470 joules. So you see that in this example, the gravity does work. The work done by gravity on the backpack is negative. The work done by the hiker on the backpack is positive. If you want to calculate the net work done, this is just the sum of the work done by gravity plus the work done by the hiker. You see that they are the same in magnitude, just they have opposite signs. The net work done is 0. Well, we could have also said this work done is 0 by just noting that since we are told that the backpack is moving at constant velocity, the net force acting on the backpack is 0. So since the net force is 0, the net work is the work done by the net force. Well, the net force is 0 and it doesn't do any work, so the work is 0.